Hey guys, we're going to continue in lesson 1.1 on determining domain range in end behavior. Alright, so recall that the domain is the set of all your x values, and your range is the set of all f of x, which most of you guys know as your y values. Alright, so the domain and range is your set of input and output values. The end behavior of a function describes what happens to the values of y as x increases without bound and as it decreases without bound. All right, so let's talk about what that means. So end behavior describes what happens to your y's, okay, f of x is the same as y, as the x values increase without bound. This is another way of saying going to positive infinity, and here's the notation for that. Or decreases without bound. Decreases means going down, so it goes towards negative infinity without bound. All right, so let's look and see what that looks like. All right, so here's a graph, and it talks about the end behavior. So we're looking at this left side of the graph where it's going down, and you can see that from 0 to -4 your x's are decreasing, so your x's are going towards negative infinity. And then your y values are on your vertical axis. Your y values are also going down, and there's an arrow, which means it also decreases without bound. So in words, as the value of x decreases without bound, the value of f of x, or y, also decreases without bound. If you want to use symbols, you can write x with an arrow, so it's x such x approaches negative infinity as f of x approaches negative infinity. Okay, so we just kind of say approaches even though it's not approaching. If you remember, infinity is just, it's like an idea. It's not really a number. It's just the idea that it continues without bound. This is the symbol that we use for this. All right, in behavior going in the positive direction. Again, if you look at 0 to +4, these are my x's. So my x's are increasing without bound. And the y values, or the vertical axis, is going up without bound as well. So again, in words, as the value of x increases without bound, the value of f of x, or my y, increases without bound. And then symbols the same way. As x approaches infinity, f of x also approaches infinity. And both of those are positive infinity. All right, so let's see if you can answer this question. Please pause the video, answer the question, and then resume when you're ready. All right, this says the graph of a quadratic function f of x is shown. How can you verbally describe the domain of f of x? So if you remember, the domain is all your x values. Your x-axis goes left to right, so this function goes both left and right with arrows, which means without bound. So that means all real numbers would be the answer. All right, again, pause the video, try to answer this question, and then resume when you're ready. All right, this question says, how can you verbally describe the range of f of x? Remember, we're still looking at this graph. So here is f of x, and the range is a continuous line that if you look at the range as your y values, it stays above +2. Since it's a continuous line, that means 2 is included. So this says all real numbers greater than 2 and all real numbers greater than or equal to 2. Since it's a solid line, 2 is included in the range. All right, next question. Please pause the video and answer this and then resume when ready. All right, suppose you can trace the curve of f of x left to right from its low point. Think about how this would change if you could trace the curve right to left from its low point. What is the end behavior? So it says we're going to trace it from left to right from its low point. All right, from left to right from its low point. So here's its low point, and here's left to right would be the in behavior on the positive side. So you're talking about the positive x's. What happens is x increases, y also increases. All right, and then it said from the low point, from right to left. So from the low point going this direction, as my x's decrease, because going to the left, that means my x's are going down, my y's go up as well. So when x is positive, y is positive. When x is negative, y is still positive. So how can we answer that? All right, so take a second to choose your answer. All right, so hopefully you picked as x goes left, y goes up, and as x goes to the right, y also goes up. All right, we're going to look at an exponential function. How do the domain and range of g of x compare to the domain and range of f of x selected? All right, take a minute to answer this question, and then we will go over. Okay, so it says, how do the domain and range of g of x compare to the domain and range of f of x? I really hope you have your lesson up, and I don't love the fact that you have to scroll up and down to see these graphs, but it's the only way I know how to do it. So if you look at g of x, you can see that the arrows go in both directions forever. So the domain, remember, is your x's. Since it goes without bound in both directions, your domain is all real numbers. If you remember, we answered that question up here for f of x. And we already answered that it also goes without bound in both directions, so it is all real numbers. So for this one, you will choose that the domain of g of x is the same as f of x. All right, what about the range? All right, the range is your y values, remember. So this would be everything above 0. And if you look back at f of x, it was everything above 2. So that's how the ranges are different. So when you look down through here, these are the 3 that relate to the range. It says they're the same. Well, we know they're not. The range of g of x is all real numbers greater than 0, while the range of f of x is all real numbers greater than or equal to 2. So that will be the correct answer. And then if you look at this, the range of g of x is all real numbers greater than or equal to 0, while the range is greater than or equal, while the range of f of x is all real numbers greater than or equal to 2. Okay, so the only difference here is that it's greater than or equal to 0. And with an exponential function, it is approaching that value, but it never actually gets to 0. So with exponential, you can't have that as a 0. So we know that has to be just greater than 0 there. All right, last one. If you will take a minute, try to answer D part, and then come back and we'll do it together. All right, this one says, suppose you could trace the curve of g of x to the left and to the right from the y-axis. What is the end behavior of g of x? So if you go up here and look at g of x again, as x's decrease, your y value approaches 0. It approaches this line here, which is 0. As it goes to the right, so as x's increase, your y's increase infinitely. So y's go to 0, and here they go to infinity. So let's see what is the best answer. All right, so x goes negative as x goes to the left. What does g of x do? All right, g of x approaches 0, so this probably is the answer. As x goes towards positive infinity, g of x also increases without bound or goes to positive infinity. All right. Hopefully you understand domain range and end behavior a little bit better. Do some practice activities, and if you have questions, remember you can always ask.